In this presentation, we will discuss how the database is tuned for performance. One of the primary requirements behind the development of database systems was the desire to provide users with quick access to the information that they need. Tuning the database to ensure that it is providing the information as quickly as possible is still a critical task in database management. Keep in mind that the database does not operate in a vacuum, and the speed with which information can be returned to the user is influenced by many factors, including both hardware and software, that cannot be addressed within the DBMS. However, in the remainder of this video, we will focus on performance issues within the DBMS. Understanding the architecture of a DBMS is important in understanding performance tuning. Remember that operations that take place in primary memory, or RAM, are thousands of times faster than operations that take place in secondary memory, or hard disk. While the complete set of DBMS memory structures and processes is quite complex, there are only a few components that need to be understood to begin performance tuning. Databases store data in data files, which can contain rows from a single table or rows from many different tables. Data files are generally grouped in file groups or table spaces, which refer to logical groupings of several data files that store data with similar characteristics. The data cache, or buffer cache, is a shared reserved memory area that stores the most recently accessed data blocks in RAM. The SQL cache, or procedure cache, is a shared reserved memory area that stores the most recently executed SQL statements or PLSQL procedures, including triggers and functions. In order to work with the data, the DBMS must retrieve the data from permanent storage and place them in the data cache in RAM. This is done using input-output, or I/O, requests, a low-level data access operation that reads or writes data to and from computer devices such as hard disks. Since RAM data cache access times range from 5 to 70 nanoseconds, and hard disk access times range from 5 to 15 milliseconds, most performance tuning activities focus on minimizing the number of I/O operations that read from the hard disk. These hard disk access times are about 6 orders of magnitude, or 1,000,000 times, slower than RAM. Every SQL statement that a DBMS executes goes through a series of steps to ensure the statement is valid and can be optimally executed. The first step is parsing, in which the statement is inspected and interpreted by the DBMS. The next is execution, in which the instructions in the statement are performed by the DBMS. And finally, fetching, in which the data are returned to the client that requested them. During the parsing phase, the SQL parsing activities are performed by the query optimizer, which analyzes the SQL query and finds the most efficient way to access the data. Parsing an SQL query requires several steps. The optimizer will check the SQL cache to see if this exact SQL statement has already been executed recently. It will validate the query for syntax compliance. It will ensure that the query's table names and column names can be found in the data dictionary, ensure that the user has proper access rights to perform the query. Then, if the SQL statement was not in the SQL cache, it will analyze and decompose the query into more atomic components. When the SQL statement is decomposed, the DBMS creates an access plan or execution plan. These contain the series of steps the DBMS will use to execute the query and return the result in the most efficient way. The execution plan is placed in the SQL cache so that if the query is executed again soon, the execution plan can be reused instead of being reformulated. During the execution phase, all I/O operations indicated in the access plan are executed. When the execution plan is run, the proper locks, if needed, are acquired for the data to be accessed, and the data are retrieved from the data files and placed in the DBMS's data cache. Recall that reducing these I/O operations, which move data from slow secondary storage or hard disk to fast primary storage or RAM, is the focus of most performance tuning activities. During the fetching phase, the rows of the query result set are returned to the client. In this stage, the database server coordinates the movement of the result set rows from the data cache on the server to the client cache. For example, a given query result set might contain 9,000 rows. The server would send the first 100 rows to the client and then wait for the client to request the next set of rows until the entire result set is sent to the client. This concludes our presentation.